There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting?
3, 2,
I hope you're all paying attention.
fire.
There's going to be a short quiz later on.
Okay.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, redenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Hello, everybody. This will be our first episode in our water vapor series.
We're going to talk about vapor pressure and water vapor in particular, but vapor pressure of other liquids as well. Pi Guy Pepin had constructed this graph of the temperature versus the vapor pressure of water.
Yeah, and this is what we'll be talking about today.
Okay.
The temperature versus the vapor pressure.
Water has a very low vapor pressure at room temperature, but it goes up with temperature.
Yeah.
And we have a plot of the vapor pressure shown on the ordinate and the temperature in degrees Celsius on the abscissa. And as you can see, the vapor pressure increases very dramatically as you increase the temperature. And the orange line here is 760 millimeters of mercury, which is atmospheric pressure. When the vapor pressure of water reaches atmospheric pressure, it will spontaneously boil, and therefore change from a liquid to a gas. Now, if you have water under a pressure lower than 1 atmosphere, all right, like at the top of a mountain, let's say the atmospheric pressure is only 300, well, then you're going to reach that vapor pressure at a much lower temperature, maybe about 75 degrees, as you can see here. So if you're trying to cook something on the top of a mountain, like boil an egg, the temperature of the boiling point will be less than 100 degrees, and you'll have to cook it longer. So a vapor pressure increases with temperature, and when the vapor pressure of the liquid equals the external pressure, the liquid will boil. Now we're going to be talking later about percent humidity. The percent humidity is a measure of how much water vapor is in the air. Let's suppose you were at a temperature...
The percentage of the total amount,
Right.
Not the actual percentage of the air that is water vapor.
Right. Let's say you're at 25 degrees. Well, the vapor pressure of water at 25 degrees Celsius is 23.8. Now, if you were in a room and the vapor pressure of water in that room was 23.8, you would feel very uncomfortable because the humidity would be 100%. But if the humidity is only 50%, then it's the vapor pressure of water in that particular room is half of 23.8, about 14, all right? About 14 millimeters of mercury. So 50% humidity, it means that the amount of water in the air is only 50% as much as it could be. At 25 degrees, the amount of water that you could have in the air is 23.8, almost 24 millimeters of mercury. That would be 100% humidity. If it tried to get above that, water would be condensing. You'd see droplets of water everywhere. Okay, so I think that about does it for this particular portion of the show. I would say that if you have a different liquid, like ethanol, it will go up faster and the vapor pressure will reach 100 at a lower temperature. Okay, thank you for your attention.
And we'll see you next time.
And we'll see you next time.